Hello friends and welcome to Shri Tech Education YouTube video channel. Now for today's discussion we have taken a topic differential gearbox in a gear trends. Now let us start discussion of differential gearbox. Now what is differential gearbox? It is a gearbox which is mounted on a rear axle of a four-wheeler or a heavy-duty vehicles, which is generally used for the two purposes. First one is to transmit the motion from the engine to the rear driving wheels. You can observe in this diagram also one transmission shaft is connected to that differential gearbox. The diagram for differential gearbox is shown in corner as a 13.21. There a propeller shaft is connected to gear A and that gear A is connected to gear B. From that gear B the differential gearbox starts, and that differential gearbox is mounted in between the rear axles, that is that rear axle connecting to two wheels. Now the first function of that differential gearbox is to transmit the motion from engine shaft to rear driving wheels. Secondly, to rotate the rear wheels at different speeds while the automobile is taking a turn. What is second function? To rotate the rear wheels at different speeds while the automobile is taking a turn. Now consider that an automobile is taking a left turn or right turn. Consider as a left turn. At that time the inner wheel of that vehicle has to rotate with slower speed and outer wheel has to rotate with larger speed, because the inner wheel has to cover a smaller distance but the outer wheel has to cover a larger distance. That's why there should be a speed difference between inner wheel and outer wheel of the rear axle. This speeds can be achieved by this differential gearbox, isn't it? Now as long as this automobile is or vehicle is running in a straight path, the rear wheels are driven directly by the engine and the speed of both wheels is same for the straight path. But when the automobile is taking a turn, the outer wheel will run faster than the inner wheel, because at the time of outer rear wheel has to cover more distance than the inner rear wheel, isn't it? And this is achieved by an epicyclic gear train. Now in this diagram the differential gearbox is shown, 13.21 diagram. The bevel gear A is known as a pinion and is keyed to the propeller shaft driven from the engine shaft through the universal coupling. This gear A drives the gear B, which is known as a crown gear, which rotates freely on the axle P. The two equal gears C and D are mounted on the two separate parts of same axle, two separate parts P and Q. You can observe in there that axle is divided into two parts, and on P part C gear is mounted, on Q part D gear is mounted. To these two gears B gear is rotating, isn't it? These two gears are mounted on these two separate axles. These gears in turn mesh with equal pinions E and F, which can rotate freely. E and F pinions are having same dimensions, same number of teeth, same diameter, and they can rotate freely on the spindle provided on the arm attached to gear B. That arm is attached to gear B, and on that arm these E and F gears are attached. When this automobile runs on the straight path, the gear C and D must rotate together. These gears are rotated through the spindle on gear B. The gear E and F do not rotate on the spindle, but when the automobile is taking turn, the inner rear wheel should have lesser speed than the outer rear wheel, and due to relative speed of the inner and outer gears D and C, the gears E and F start rotating about the spindle axis and the same time revolve about the axle axis as well. This relative motion, due to this epicyclic effect, the speed of inner rear wheel decreases by certain amount. This and the speed of outer rear wheel increases by some amount. This may be well understood by drawing the table of motion of epicyclic gear train in differential gearbox. We can prepare the table of motion for this differential gearbox as apply the four conditions as usual for all the elements in the gear train. Now elements I can write as gear B as the first, because arm is connected to that gear B. In usual practice, while preparing table, first we are writing as arm. Therefore arm is connected to B, that's why I will consider that first as a gear B. After gear B, I will consider any of the gear of C or D first for giving +1 revolution. Now I will give +1 revolution to gear C. Next, to C gear, which gear is in mesh? Gear E is in mesh. Next, to E gear, D gear is in mesh. Therefore next column will be for D gear. These all four are the elements in that gear train. Forgot about A because from B onwards our differential gearbox is there. So apply first condition as usual, fix the arm and give +1 revolution to any of the gear. So here I will fix the gear B and give +1 revolution to gear C. Therefore for gear B revolution of element will be 0, for C it will be +1, for E after applying velocity ratio it will come as a TC upon TE. How it has come? For studying this, observe or watch my previous videos. You can understood how to write the velocities of elements in that column. So by applying velocity ratio we will get it as a TC upon TE. For gear D, again apply velocity ratio, you will get it as a TC upon TE into TE upon TD. But as C and D gears are having equal dimension, equal gears, I can write TC is equal to TD, that is number of teeth on C and number of teeth on D gear as equal. Therefore these will get cancelled out. TE gears also cancel out, remaining will be -1. The revolutions of gear C are, I have made in anti-clockwise direction. Gear E will rotate in. Now this is also very important to give the signs. How I have given plus sign for gear E. If gear C I have considered as rotating in anti-clockwise direction, gear E as its axis is vertical, and if I am observing from downward side of that gear E, I cannot judge in which direction it is moving. That's why for the case of a gear which is horizontally placed like E gear, I will always assume the sign for rotation as a plus, whatever may be its meshing gear sign is. Therefore when gear C is rotating with plus sign, E gear I have considered also rotating with the plus sign. And if E is rotating with plus, D I have considered it as a minus with minus sign, because it is a vertical gear having its axis horizontal, not a vertical axis, isn't it? This is the first condition. Apply second condition. gear B is fixed and gear C is rotated with plus X revolution. Instead of plus 1, now here is a plus X. Multiply by X for the first row. You will get a second condition. In third condition, add plus Y revolution to all elements. Add plus Y to all. In last total revolution row, it will be summation of second and third condition. Therefore 0 plus Y, Y. X plus Y, you will get X plus Y. For E gear, it will be X into TC upon T plus Y. For D gear, it will be minus X plus Y. That is Y minus X. The last total motion of all elements will be the formulas for getting revolutions of each element. Now here you observe that if gear C is rotating with X plus Y revolutions, gear D is rotated with Y minus X revolution. That means gear D is rotating with slow speed as compared to gear C. That means Q axle on which D gear is mounted is rotating with slow speed. That means right hand wheel is rotating with slow speed, and left hand wheel, that is axle P, is rotating with more speed. That means this vehicle from your view is rotating in the right hand side, isn't it? This you can conclude from this table of motion as well. Now we will see one problem based on this epicyclic gear train differential gearbox. Now whatever differential gearbox, standard differential gearbox, same differential gearbox I have considered here, and the problem is the figure shows a differential gearbox used in a motor car. The pinion A on the propeller shaft has 12 teeth, and the gear with the crown gear B which has a 60 teeth. So gear A and gear B number of teeth are given, so I can find out a velocity ratio. From velocity ratio, what will be speed of gear A or B, isn't it? Second, the shaft P and Q from the rear axle to which road wheels are mounted. If the propeller shaft rotates with 1000 rpm, first condition, propeller shaft rotates with 1000 rpm, that means NA is 1000 rpm. From that NB you can calculate by speed ratio. If driver is A gear, driven is B gear, therefore NA upon NB is equal to TB upon TA. From that NB is equal to NA into TA upon TB. You can find out NB because TA and TB teeths are known. NA is also given as 100 rpm. And the second road wheel attached to the axle Q has a speed of 210 rpm. That means gear D has 210 rpm revolutions speed. This is the second condition. Always remember in problems of epicyclic gear train, while solving by tabular method, you should know the two conditions, or the two conditions should be given in the problem, and these two conditions are given here. And what is asked? Find the speed of road wheel attached to axle P. That means speed of gear C is asked. Prepare the table of motion as we have prepared for epicyclic gear train, because it is a standard epicyclic gear train used in automobile. So we will get the last table of motion row having formulas. And what is the condition given for us? This condition is the speed of gear B is 200 rpm. In this NB is 200 we have calculated. Therefore what is the formula for speed of B gear? It is plus Y. Plus Y is equal to 200. What is second condition? The speed of road wheel attached to axle Q, or the speed of gear D, is 210 rpm. What is formula for D gear? Y minus X. Y minus X is equal to 210. Therefore put here value of Y, you will get X as a minus 10. Therefore speed of road wheel attached to axle P can be found as to P gear shaft, which is gear mounted on that C gear. What is formula for that C gear? X plus Y. So X plus Y is equal to speed of gear C. What is X? Minus 10. What is Y? 200. Therefore speed of gear C will get as a 190 rpm, and this is our answer. Like this you can solve any problem based on this differential gearbox. So thanks for watching my videos. Subscribe to this channel. Thanks.